This is Mr. Martin. This is the conclusion of the video notes for Precalc Honors, section 8.5. We're talking about the binomial theorem. And we're going to take a look at Pascal's triangle, which we have looked at a little bit in class. So just a little refresher here. Again, it's just a convenient way to find the coefficients of a binomial expansion. And once we have the coefficients, we know the pattern for the exponents, where the exponents of the first variable is going to go from n down to 0, and then the other variable is going to go from 0 up to n. So again, our Pascal's triangle starts with a 1, and again that's for n equals 0, and then we have a 1 and a 1, and that's for n is equal to 1, and then we have a 1, 2, 1. So we're going to have 1's always on the outside, because whenever we have n choose 0, that's going to be 1. That's going to be these 1's on the left. And anytime we have n choose n, it's also 1. Those are the 1's on the right side. So then we have 1, and then we add 1 and 2 to get 3, 2 and 1 to get 3, and then our ending 1. And then we have 1, 4. 1 and 3 is 4. 3 and 3 gives me 6. 3 and 1 gives me 4. And then our ending 1. Let's do 2 more rows. 1, 5, 10, 10, 5, 1, and then 1, 6, 15, 20, 15, 6, and 1. Okay, and again, remember that this is for n is equal to 0. This is for n is equal to 1, n equal to 2, n equals 3, n equals 4, n equals 5, and n equals 6. Okay, so keep in mind, when we have our binomial raised to the second power, n is equal to 2, we get a trinomial. Okay, so we get 3 terms. So we're always going to have one more term than the degree of the polynomial. Alright, so let's take a look how we can use Pascal's triangle to expand this. So we want n is equal to 4, so let's scroll back up here and look at our exponents for n is equal to 4. We've got 1, 4, 6, 4, 1. Okay, so our coefficients are going to be 1, 4, 6, 4, 1, and we know that n is equal to 4. So we're going to start out with our coefficient of 1, and then our first term is a 3x, and our second term is a 2, and I'm going to go through and put in all my coefficients first, and then I'm going to go back and put in my exponent. So you can do it however you like to. My next coefficient is a 4, so I have 4, and then I'm going to have 3x raised to something and 2 raised to something. And then 6, again I'll have a 3x, we'll fill in the exponents in just a minute. And then 4, and there's a 3x, there's a 2, and then a 1. So I have 1, 4, 6, 4, 1. And then 3x and 2. So I know we're going to start with my value of n here, so that's going to be 4 and 0, because my exponents always have to add up to 4, and then we're going to decrease for the first variable, so that's going to be a 3, and increase for the second one, and a 1, and then 2, 2, 1, 3, and then 0 and 4. Alright, and then we could just start simplifying. So we've got 3 to the 4th and x to the 4th, so that's 81 x to the 4th, 2 to the 0 is 1, plus, and then we've got 4 times 3 cubed, which is going to be 108. So I have 108 from 4 times 3 cubed. Then I'm going to multiply it by 2. So I get 216, and then x cubed. And then for my next one, I have 6 times 3 squared times 2 squared. So that's 6 times 9 times 4, which is also 216. And then x squared is what's left there. And then I have 4 times 3 times 2 cubed, which is 8. So that's going to be 96. And there we just have an x. And then lastly, I have 1 times 3x to the 0, which is just 1, and then 2 to the 4th, which is 16. So, either method, binomial theorem or Pascal's triangle, I think they're equally as quick. You want to make sure that you practice both methods, because again, if I asked you to find the 8th term of 2x minus 3y raised to the 15th, you're not going to want to use Pascal's triangle to find that coefficient. You're going to want to use the binomial theorem. So go ahead and see if you can work out examples B and C. Notice you just have to find the 6th term here. And over here, you just have to find the coefficient. All right, and since this is raised to the 11th, you may want to use the binomial theorem. Again, since this is raised to the 8th, and then you want to add one more row to your Pascal's triangle up here, actually 2 more rows, again, you may want to use the binomial theorem. So come to class with those finished, and we can check answers and go through those and answer any questions the next time I see you. All right, we'll see you next time.